Hey, so I reset this test for you several days ago, and I hadn't seen you to ask any questions or anything like that. So I'm gonna go ahead and just make this video, and hopefully it's something that you can use. Watch it, take a look at how I solve some of the problems, maybe even take some notes, and then the test is reset, so it's ready for you to go whenever you're ready. So the first question you missed was number 2. It asks for the solution to the system of equations. You know, with multiple choice, it's interesting. You can start plugging in ordered pairs to see which ones work, but unfortunately you can see here this is one where the answer is infinitely many. You had chosen no solution. So in that case, we do actually have to solve. So what we have here is y equals 3x minus 4, and we have negative 3y equals negative 9x plus 12. This is set up nicely for substitution. So what we're going to do is we're going to take this part of the equation and we're just going to substitute it down into the bottom where we see the y. So when you have one equation solved for y or for x, substitution works really well. So I'm going to take that bottom equation, I'm going to rewrite it here so you can see exactly what I'm doing, and I'm going to substitute in the top equation right in here for y. So the negative 3 comes out in front, and I'm going to multiply that times the 3x minus 4, and I get negative, still have negative 9x plus 12 on the other side. So the first thing I'm going to do is distribute, so that's negative 9x plus 12 equals negative 9x plus 12. These two sides are identical. The left side equals the right side. And when that happens, you have infinitely many solutions. It means that every ordered pair works in the system because actually these are the exact same equation. If you take that very first equation and divide everything by negative 3, if we get rid of this coefficient in front of the y, you would get y equals 3x minus 4, which is what the first equation is. If you ended up with something here like this, and I'll show you if I take it even a step further, if I add 9x to both sides, what's going to happen here is the variable is actually going to completely eliminate, and I end up with 12 equals 12. And I tell my students that this is a true statement, 12 equals 12. Because it's a true statement, again, it's infinitely many solutions. However, if you lose your variable, like we lost the 9x's here, and what you end up with is not a true statement, let's say 12 equals 20, okay, that's not true, that's when we would say no solution. Number 3 asks you to write the inequality in slope-intercept form. So when you put something in slope-intercept form, you're trying to solve for the y variable. So the first thing we always have to do is move the x to the other side. I do that by adding 8. Since it's a negative 8, that's the opposite. I'm going to bring down 4y. It's greater than or equal to. I'm also going to squeeze the 8x up in here in between the inequality symbol and the minus 52, because usually slope-intercept form is y equals mx plus b, so we have the mx term first. Now I have to divide everything by 4. So dividing by 4 gives me y is greater than or equal to 2x minus 13, and you can see that that is this answer choice. The inequality symbol does not get flipped here, and I think in a later example we'll see when and why it does get flipped, but it should stay the exact same, pointing in the same direction. Same thing on number 4. We have negative 6x plus 3y is greater than or equal to negative 45. So again, we're going to move the x term all the way to the other side. So you do that by adding 6x to both sides. Because it's negative, we do the opposite. We're going to bring down a 3y is greater than or equal to, again, I'm going to squeeze that 6x term in front of that negative or that minus 45. Now everything gets divided by 3. We have to get that coefficient off of the y, so we undo, multiplication by dividing, so we get y is greater than or equal to 2x minus 15. And that's the option here. 5 is asking for the solution to this system. Oh good, this is one that is no solution. So when you again have two equations that are solved for y, it's easiest to just take one of them and plug it in where the y is on the other equation. So I'm taking that negative 2x plus 5 and I'm plugging it in for the y on the second equation. So basically these two parts are going to equal each other. Negative 2x plus 5 is going to equal negative 2x plus 20. Hopefully you can recognize that if I add, get variables on the same side, 2x to both sides, again I lose that variable, similar to the first example I showed. I bring down 5, the equal sign, and the 20, and you can see that this is not a true statement. 5 does not equal 20, so then we say no solution. Choose the linear inequality that describes the graph. So you need lots of things here. We need an inequality symbol. You need a number in front of the x for slope, and you need a y-intercept. So I'm going to write, you need an inequality pointing the right direction. We need slope, and we need y-intercept. So we're going to set this up, it looks like, in slope-intercept form, which is y. I say y equals mx plus b, but it's an inequality, so instead of the equal sign, we'll have an inequality. So I'm going to start with the y-intercept, because that's the easiest thing to find. That's right here. It's where does the line go through the y-axis, and that's at negative 2. So we're going to have a minus 2 in the back. Next, we need to figure out the slope, and the slope is found by looking at the grid and looking for where does the graph cross another like intersection piece here. You know, we're looking at these places where the grid intersects, and it looks like here. So if we count this slope from the bottom to the top, we go up 1, 2, 3, 4, and we go over 1. So the slope is 4 over 1. That's in the positive direction, so the slope is 4. So right now we have 4x minus 2. If I look through the choices, there's actually only one that had positive slope. All of these other three had negative slope. In order for those to have been correct, your line would have had to go the opposite direction. That's a line that has negative slope there that I've just drawn. So it's definitely option D here, this bottom one. But let's talk about the inequality symbol. So when you have an inequality solve for y, you can look at the shading to do less than or greater than. So you can see how this line kind of tilts to the right, and the shading here happens underneath or below the line, we say. So below the line shading is less than, or it could actually be less than or equal to. In this case, it's less than because this graph's line is dotted. So we're not including the actual graph. Okay, sorry about that. So anyway, the line here is dotted, which means we aren't including the line itself, so we would use this symbol versus this one. So let me erase all of this now because the line that I drew to put the inequality symbol on made it look like less than or equal to. So y is less than 4x minus 2. We needed the y-intercept, we needed the slope, and we needed the correct inequality symbol. Okay, again, putting this in slope-intercept form, it looks like several of these were missed, so hopefully me going over a lot of these examples will help. So the first thing we want to do is add, again, 6x to both sides. We want to get the x term on the other side. So that's 2y is less than or equal to 6x plus 42. We want to squeeze that 6x up in front of the 42. Everything gets divided by 2. There's no symbol flipping here. We're not dividing by a negative. That's the only time you flip the symbol is when you divide by a negative. So it's y is less than or equal to 3x plus 21. Number 10, you're asked to again solve by substitution. So the bottom equation this time is solve for y, so I like to circle this. This equals y, so that means I can put it right there. So I'm going to rewrite that top equation, substituting in the negative 3x plus 11 for the y. So this first equation, draw a line over here, it's 3x plus 2 times negative 3x plus 11. There's the substitution, and it equals 7. So the first thing we're going to do is distribute. This gives me a negative 6x plus 22. When I combine like terms, 3x plus negative 6x is negative 3x plus 22 equals 7. I'm going to subtract 22 from both sides. This gives me negative 3x equals 22 minus 7 is 15, so negative 15. Divide both sides by negative 3, and I get x equals 5. So the first part of the ordered pair is going to be 5 comma something. So I always tell students, now go look at your answers right away, because if there's only one that has a 5 in the x coordinate, and there is, this is a 6, and a negative 4, then you know that that's your answer right away. If there were multiple answers with a 5, that means you would have to plug the 5 back into either equation. The bottom one here is the easiest. Plug the 5 back in, so negative 3 times 5, if you can see where my cursor is here, that's negative 15, and negative 15 plus 11 is negative 4. So you do in fact get the right y value for the ordered pair. Solve using elimination. This one is set up really nicely for you to just eliminate right away. You don't have to multiply anything here because the x's already have the same variable with opposite signs. So positive 3x, negative 3x, those cancel out. Now I just add up my y's. Negative 4 plus 2 is negative 2y. 9 plus 9 is, sorry about that, that's the bell. 9 plus 9 is 18. So we divide both sides by negative 2, and we get x equals negative 9. Again, only one answer that has negative 9 in the correct spot for the x value. If you needed to find the y, so if there was another ordered pair that had negative 9 in for x, again, you would have to substitute the negative 9 in, or plug the negative 9 in for x either here or here, and then solve that equation for y to figure out what y is. I think we might only have 2 left. 14, again, solve using elimination. So again, this one is set up really nicely for the y's to eliminate this time, because you'll notice that there's a positive 2y and a negative 2y. So those are going to cancel. Those basically give you 0y. So now add everything else up. 2x plus x is 3x. Negative 8 plus negative 1 is negative 9. Divide both sides by 3, and we get x equals negative 3. Again, only one answer over here that has negative 3 in the x spot for the coordinate, so no need to plug it back in, but you could plug the negative 3 in either here or here to give you the y value. And the last one is just writing an equation, an inequality. It says you have $32 to spend at a music store. Each cassette tape costs $5, and each CD costs $9. Oh my goodness, this problem was written a long time ago. Do you know what a cassette tape is? Do you still buy CDs? I don't even know if people buy CDs anymore. Write a linear inequality that represents this situation. Let x represent the number of tapes and y the number of CDs. So the big thing here is that you have $32 to spend. So right away, whatever we do on the left-hand side has to be less than or equal to 32. We can't go over $32 because that's all we have. And it looks like that was the difference for you, the inequality, the correct one versus the one you chose. So again, cassette tapes are $5 a piece, and x represents cassettes, so it'd be 5x, plus $9 for CDs, and CDs are y, so 9y. So just maybe it's, you might be getting these flipped around, but this is less than or equal to. That's how that one's read. So whatever you spend at the music store has to be less than or equal to 32, because that's all the money that you have. Okay, so it looks like that's it. I'm going to have to probably link this to YouTube so that it's probably too long to send through email. Again, the test is reset, so please give it a try as soon as you can. You're a little bit behind, and I'm just hoping that you can get caught up by the 19th. Let me know if you have any questions. I'm available pretty much to answer email all the time. Thanks for your time.